exponential functions in the form of exponential growth or exponential decay. So remember that we said an exponential function grows when that base is greater than 1, right? And then it decreases. It's a decreasing function if that exponential growth, that base, is in between 0 and 1, right? Remember how we talked about functions? As x gets bigger, y gets bigger, that's increasing. As x gets bigger, y gets smaller, that's decreasing. Well, exponential decay and exponential growth kind of work the same way. So this is your formula for exponential growth. Looks a lot like the word problem that we did yesterday. This is your formula for exponential decay. And I'm going to tell you what all those little variable terms mean. So y is just the total amount, right? We like plug in for x and we figure out what the total is, or we plug in for all these numbers and we figure out what the total is. So y is just our total amount when we're all done. That's what we end up with. A, what does a represent in our exponential function? The initial value. Who said that? Was that you? Good job, Anaya. Initial value. Okay. What does R stand for? It was like our common ratio, which is our base or our multiplier, right? So we're going to call it our base. And if we are doing a growth, we're using the +1 formula right here. And if we're using a decay, we're going to take that base and do the subtract 1. And then T is your time. Usually your time interval, like sometimes, typically they're in years, but not always. So it's just your time interval. So we're going to look at what the Gonzalez family, how much money they made when they bought their condo. So I'm assuming it's condo. Yeah. Okay, good. So the Gonzalez family, it's so weird how I can't put that on there. The Gonzalez family bought a house for $279,000. So this is their beginning cost. What does that represent in that equation? Say that again. Yeah, who said that? Who's saying initial value? Again? Yes, A. So put a box around that and label it A. The condo will appreciate. So do you guys know what it means to appreciate or depreciate? If something appreciates, it grows in value. If something depreciates, it decreases in value. So this means that it's going to grow in value, which means it's going to be a growth model, okay? It says it's going to appreciate how much? 5%. So this is my multiplier. This is my base, but we always want to write this as a decimal. I'm going to actually put as a decimal up here. As a decimal. So how do I turn 5% into a decimal? We can write it over 100. Yeah, sure. 5 over 100. And then I could put that into my calculator. And 5 divided by 100 is going to give me 0.05. Or I could remember that I just take the percent and I move the decimal 2 places to the left. Either one of those will work. Use what method works best for you. Okay. So we know what our base is. And it says, how much will the house be worth in 5 years? That's my time. So we're going to use the exponential growth model. Y equals A times 1 plus R to the power of T. And we're going to plug in our numbers. So Y equals, well, we said our beginning amount, our initial value is 279,000. And I have to take 1 plus my rate, which is 0.05. And I have to raise that to the power of T, which is my time interval. And how long am I going to do this? For 5 years. So before we put this into our calculator, I'm going to actually simplify this a little bit. I'm going to write 279,000 times 1.05 to the power of 5. And I'm just going to put this into the Desmos calculator because I just want you guys to see how to do it, I guess. Cosmos Scientific. So 279,000. I'm going to use a parenthesis, but I could use the times button, right? And I have 1.05 raised to the power of 5. So what's the value of my house? Just to the nearest whole dollar. What's the value of my house after 5 years? It's right up there. Someone say the number. Yes, 356,082. So y equals, and it's a dollar value, 356,082. Mrs. Bishop. Got it. Thank you, ma'am. Evan, your notebook's in. Go grab it. Does that make sense? Do you guys feel okay with that? Okay. You guys do the next one. I'll read it out for you and we'll label everything and then you're going to calculate it. So it says in 2000, the population of a city was 1 million. So what should I do? What's my initial value? 1 million. So I know it's written in words, but it's still a number. A equals 1 million. I'll even write that off to the side. So 1, 1, 2, 3, 1, 2, 3. There you go. It says it's increasing. So this is going to be growth or decay? Growth at a rate of 3%. So how do I show my base or my R? I should write that as an R. How do I show my rate? 0.03. Good job. 3% is 0.03. And it says it continues to grow. What is the population now? So we started in the year 2000 and we're wanting to know what the population is now. So what is my time interval? 22 years. Yeah. Okay. Can you guys plug that in? Tell me what you get. And just round to the nearest whole person because we're not doing half of a person. They probably wouldn't like that. Some of you guys didn't write the names on the back of your papers. You're not going to get points for that. Anybody have an answer for this? What'd you get, Lanaya? That's not what I got. I need to do mine again on a calculator. You might be right. I used a non-scientific little cheesy calculator. Times. Yeah, that's not what I got. I just did it again. Did someone else get something different? How did you set it up, Lanaya? Aren't we doing 0.3? It's 0.3. It's a 3%. That's your mistake. What'd you get, ma'am? Perfect. That's what I got as well. Yeah, that's how I set it up. Y equals 1 million times 1.03 raised to the power of 22. Y equals 1,916,103 people. Okay. So for our next question, I'm going to leave that up there for a second. Will someone let Evan back in? He's stuck outside. Is everyone done with that example? Can I move on? Okay. So for our next question, it says a cup of coffee contains 130 milligrams of caffeine. So this is what we're working with. This is our A. If caffeine is eliminated from the body at a rate of 11%, so this is my rate, and I heard someone say decay. Who said that? Good job. It eliminates at 11% per hour. How much caffeine remains in the body after 6 hours? So this is my time. So let's see. Y equals my beginning amount, 130, times 1 minus, because it's decay, I have to write 11% as a decimal, which is 0.11, to the power of 6. And you should be able to do all that in your calculator at one time as long as you use parentheses to group it. What'd you get? Huh? I was asking Alexis. I thought she had it. What'd you get? No? Okay. What'd you get, Lainey? 64? Yeah, no, I think I rounded it to, I wrote 64.6, but that's okay. I think you're right. 64.6 or 64 milligrams is what's left. Huh? If you rounded it up, it would go to 65. I just rounded it. I just left it at 64.6 milligrams. Okay. Are we good with that? Maybe yes, maybe no. Okay. All right. So the next one you're going to set up. So you're drinking a Red Bull. How many of you guys drink Red Bulls or Monsters? Yeah. Like I probably drink 3 Monsters a day. How many milligrams of caffeine are in this? We probably don't want to know. Honestly, it doesn't say how many milligrams of caffeine are in this. I know it's not. I'm trying to wean myself off of them. Thank you. My doctor yelled at me too. Okay. Okay. Anyway, so 80 milligrams. That's what we're starting with. This is my A value. Okay. We know that the body breaks down your caffeine out of your body per hour at what rate? We know it from the question above us. What's the rate that your body disseminates or eliminates caffeine? 11%. The rate at which your body can eliminate caffeine is 11%. So we're still going to use that same rate. And we just need to know how long. We're trying to find the T. Right? We're trying to find the T. And we want to get it totally out of our body, meaning Y equals 0. So actually, you guys can't probably do this one on your own. We're going to do this together. So let's set this up really fast. So I want to know when 0, total amount of caffeine is gone. So 0 equals 80 times 1 minus 0.11. We're trying to find T. We're trying to find T. So to actually solve this, you guys have to do logarithms, and you don't know how to do that. We don't get max out of the tree yet. I think that's algebra 2 here, or like math 2. So we're going to just trial and error. Okay. We're just going to do trial and error. So how long do you think it's going to take? If it takes after 6 hours, look at the question above. If it took 6 hours to break it down in half, like 6 hours, cut it about in half, what do you want to try? Because we know it's going to be more than 6. Give me a number. 12. Okay. So let's let T equal 12. So when T equals 12, Y equals, so here's what I'm going to do. In my calculator, I'm going to take 80 times 1 minus 0.11 to the power of 12. And when I do that, I find out that I still have 19.75 milligrams, or actually 0.76. I'm just going to leave it as 19.76. 19.76 milligrams. Did someone else get that? Yes or no? Yeah? Okay. So we have to do it again. So what number do you want to try now? You want to go for 20? See if it breaks it all the way down and then we can work backwards, or do you want to just keep going up by 2 or 3 at a time? It's your choice. 20? Okay. So when t equals 20, so that's going to be in your calculator 80 times 1 minus 0.11 to the 20th. What do you guys get? Yeah, 7.77. So it's still not gone. So what do you want to try now? You notice how the rate of decrease is like, you know how it's slowing down, right? That rate is slowing down. Okay, what do you want to try? 25? So when t equals 25, what do you guys get? Yeah, like 4.34. Still not gone. Okay. So that means that the 80 milligrams of caffeine from your one Red Bull is still in your body after 1 day. Crazy. So what do you want to try now? Try 30. Okay. So t equals 30. What does y equal? Yeah. Isn't that crazy? It's still there. So what do you want to try now? Good job. T equals 35.
Still there.
I know, isn't that crazy? Get out, get out. So I'm just going to tell you, when t equals 50, when t equals 50 hours, you have 0.2 of a milligram of caffeine left in your body. Just so you know. We're going to be done with that. Okay. All right. In 2010, the population was 280,000. The rate of decrease, this is a decay, is 1.5%. So R equals, if I move it 2 places to the left, 0.015. What is the population in 2016? So what is my T? I started in 2010 and I'm asking about the population in 2016. T equals 6. So Y equals 280,000. 1 minus 0.015 to the power of 6. What do y'all think? Anyone? Yeah, 255,726 people. Okay. Are we good with this? Okay, now let's talk about compounding. And we need to do the half-life questions. Okay. So for the half-life questions, So it says the half-life of radioactive material, this is true, is defined as the time that it takes for 1/2, 50% of the quantity to eliminate. This is the formula that we're going to use really fast. So radioactive carbon is found in all living organisms, and it has a half-life of 5,730 years. So we're going to consider an organism that has that carbon-14, and it has 500 kilograms. So we're trying to figure out if the organism lived 5,730 years ago, what is the concentration of carbon today? And I know there's not a whole lot of room, so I'm going to kind of shift over to this side because I know that I write big because I want you guys to see this. So this is the function that we're using because we have to take our time and divide it by 5,730. So we know that A, well, actually, it's already written for us. I don't even have to label all that stuff. So for part A, y equals 500 times 50% is the same thing as 1/2. Our time is 5,730 years ago, 5,730 divided by 5,730, right? Because you see in the equation, it says take your time and divide it by 5,730. Well, what is 5,730 divided by 5,730? It's 1. So 1/2 to the power of 1 is just, so what's half of 500? 250 kilograms. Okay. So the second question says if the organism lived 11,460 years ago. So we're replacing the T, we're keeping the same setup, but we're replacing the T in the top of that fraction with 11,460. So y equals 500 times 1/2 to the 11,460 divided by 5,730. Well, what is 11,460 divided by 5,730? Yeah. So that's the same thing as saying y equals 500 to the 1/2 times 1/2 to the second power. Well, 1/2 times 1/2 is 1/4, and 1/4 of 500 is 125. Okay. Question C says, if the organism lived 28,650 years ago, how much carbon would it have? So I'm going to use the same y equals 500 times 1/2 to the power of, and I'm going to divide. My exponent is going to be 28,650 divided by 5,730. What is 28,650 divided by 5,730? 5. So that's the same thing as saying y equals 500 to the 1/2 times 5. Well, 1/2 times 1/2 times 1/2 times 1/2 times 1/2 is 1/32. So 500 divided by 32 is 15.625, right? Did you guys get that? Okay. Now let's do question D. Question D says, okay, same setup, only this is what we're dividing. So y equals 500 times 1/2 to the power of 63060 divided by 5,730. Well, that's the same thing as y equals 500 to the 1 times 1/2 to the power of, it's like 11, isn't it? 11.000 something. So we're just going to say it's 11. So what is 500 times 1/2 to the 11? You guys all have calculators sitting in front of you. Someone do it up. What'd you get? You turned it into a fraction? Is that what you did? So say your fraction again. I didn't hear you. 125 what? 125. 125 divided by 512. Yeah, you're going to get the same decimal that I got. I wrote my answer as a decimal. 0.244. Okay. Are we good with this? Do we have this written down? So you do have a question in your homework about half-life. And this is the formula that you're going to use. This is how you figure out the half-life. The only difference is this starting amount. You may be starting with 100 kilograms or 200 kilograms or whatever, but that's how you calculate half-life. Okay. Are we good? Okay. We need to talk about compounded interest. So do you guys take a business class or anything like that? Do they offer that here? Okay. So businesses, anytime you purchase a home, a car, whatever, you're not paying simple interest, you're paying compounded interest. And your interest is compounded differently depending on the type of loan you have. Some loans are compounded quarterly or annually or monthly. So I want to write the formula out for you first. So the formula for compounded interest is capital A equals capital P times the quantity 1 plus R divided by N to the power of N times T. So that's what that looks like. I don't want to talk about what all of those like letters mean. So A, what we end up with is what we're equaling, right? So A is probably the total amount. It's what you end up with when you're all done. P is the initial value. It is often called principal. It's often called principal. That beginning value is often called principal. Remember that R stands for your rate, and we want to write it as a decimal. N is the number of time periods. Well, it's actually, I don't want to write time periods. It's the number of compounding periods. Number of compounding. And then T is the time. So typically time is given in years, especially for interest. Okay. So typically our time is going to be in years. So if you think about in a whole year's time, if we compound it quarterly, how many times is that getting done? 4. So I just want you to know that quarterly, this is your N value. That means that N equals 4. These are your N values. Okay, so N equals 4. If we say quarterly, you're just going to say that N equals 4. What if we say that something is compounded annually? How many times are we compounding it? Once, yeah. Annually is just one time per year, right? What if we say something is compounded monthly? 12. What if we say something is compounded semi-annually? 2. Which is different than biannually. Does anyone know, like, have you ever heard that someone gets paid bi-weekly? They get paid every 2 weeks. Biannually means every 2 years. So how do I show 2 years in 1 year time? Awesome. 1/2. Weekly, how many weeks are in a year? 52. And daily? Yes, thank you. Okay. I can't believe you guys didn't know 52 weeks. Okay, so we are going to do, I think, just really we'll do 2 of these examples, okay? So if $1,000 is invested, this is my P, capital P, my principal, and it's invested at a rate, This is my R, and I'm going to turn it to a decimal right now, 0.0725. And it's compounded quarterly. That means N is 4. For 15 years, that means T is 15. I think that we have everything that we need to plug into our formula. Okay. What do you guys think? Do you feel okay with that? All right. So P 1000 times 1 plus, well, my rate is 0.0725 divided by 4. And I have to take 4 and 15 and multiply them together. That's my exponent. 4 times 15 is 60. So you can do that all on your calculator if you use parentheses. So 1000 times 1 plus, put a parenthesis around that division problem, 0.0725 divided by 4, close your parenthesis again, and then raise that to a power of 60. What did you guys get? Another way you could do it is you could take 0.0725 and divide it by 4. I don't know if that's easier. Yeah. So remember that your exponent is n times t, or t times n. So I took 4 times 15. I should write that down. Okay. I'm listening. Go ahead. What'd you get? Oh, no, that's not right. Here, I'll go to, what'd you get? That's what I got, 2,938. Do you want me to show you in Desmos what this looks like? Let's pull it up really fast. So in Desmos, I have 1,000 times 1 plus 0.075 0725, sorry, divided by 4, close your parenthesis, to the power of 60. Okay. You see that? Are you okay with that? All right, let's set up the next one, solve it, and then the last two we'll just set up. You guys can solve them on your own. So 25,000 or $2,500 P. This is my R. 0.042. Compounded semi-annually, that means N is 2, time is 20 years. So 2,500 times the quantity 1 plus 0.042 divided by 2, all to the power of 2 times 20 is 40. Do you guys see where I got that? 2 times 20 is 40. Anyone solve it? What'd you get, Miss McKinley? Yeah, I'm just going to leave it as 5,740. Yes. So if we were to set up P, or set up number 3, 500,000 is P. My rate is 0.0325. It's compounded monthly. That means N is 12 and T is 10. So we're not going to solve this one. We're just going to set it up. So we know that capital A equals 500,000 times 1 plus my rate, 0.0325, divided by 12, raised to the power of, let's see, 12 times 10 is 120. I'm just going to tell you what the answer is. 691,711. So for this last one, calculate using tables how long it would determine to like double your investment. So your principal amount, your rate, and it's compounded quarterly. So you're trying to figure out the T. This is another kind of one of those guess and checks. So I'll set it up for you. We want to double our investment. So that means we want A to equal 6,000. Again, you guys don't know how to do logarithms. So it would look something like 6,000 equals 3,000 times 1 plus 0.025 divided by 4, all to the power of, we don't know, 4t. So here's what I did. I started multiplying, raising it to powers of increments of 4, like multiples of 4, 4 times 1, 4 times 2, 4 times 3 to figure out how many years. Does that make sense? So if you take and let the time equal 28, when the time is 28, you end up with $6,028.11. So it's going to take about 28 years. Again, I just had to like guess and check on that. So you guys, for your homework, you are doing page 25. You are doing page 25.